Hi guys, in the next couple of videos we're going to consider some rules for differentiation, right? These are rules that we can apply to different situations to help us differentiate. And the first of these is going to be the chain rule. But before we start on that, let's have a quick review, okay? Let's try to differentiate this function here, 2x plus 3 squared. Now at this stage, probably what you'll do is you'll expand this bracket here, right? So you'll square this all out, so you'll get 4x squared plus 12x plus 9. Okay? Then having got that, you'll differentiate this polynomial here. So you'll get dy dx is equal to 8x, right? Bring the power 2 down, reduce the power by 1, plus 12. And then the 9 differentiates to 0 because it's a constant. So we differentiate this function here and we get 8x plus 12. But let's now consider the next function. Let's say instead of having 2x plus 3 squared, we have 2x plus 3 to the power of 10. Now it's probably going to be very difficult, isn't it, to sit there and expand this bracket out 10 times. So what could be a better way of differentiating this function? Well, if you like, you could consider it this way. You can consider that we have one function here, 2x plus 3. That's like the small function on the inside. And then we have a bigger function here, which is like x to the power of 10, right? So what we've got is we've got a big function in green, and then we've got a little function in yellow on the inside. If you're not sure about that, what I'm trying to say is this. Imagine that we've got a function f of x, and f of x is the function x to the 10. Right? We know how to differentiate that function already. That's fairly straightforward. And then we have another function, g of x, which is equal to 2x plus 3. And we know how to differentiate that too. Well, what I'm really saying here is that the function y is actually equal to this function f of x, but instead of x, what we've put inside is 2x plus 3, or if you prefer, the function g of x. Right? In other words, what we've got here, we've got a small function there, g of x, is going inside the bigger function, f of x. And that's at the heart of the chain rule, right? What we are doing is we are differentiating a function of another function. And I'll repeat that again. For the chain rule, we are differentiating function of another function, right? Where we've got one function inside another. Now, how can we go about differentiating this? Well, what I'm going to say is we take the small little function on the inside, right? That little thing there, 2x plus 3, and we're going to make a substitution. We're going to say, let u equal 2x plus 3. And that therefore means that we can write the function y. The function y is equal to u to the power of 10, right? So all I've done is I've just replaced 2x plus 3 with u. Well, now let's think, can we differentiate this function here, u, with respect to x? In other words, can we find du dx? If we differentiate that function, we differentiate 2x, we'll get 2. We differentiate 3, that's a constant, so it just goes to 0. So du dx is 2. And then we're going to consider the y equals u to the power 10. Can we differentiate that, but differentiate it not with respect to x, but with respect to u, dy du? If we differentiate that, well, we just apply the same rule. We bring the power down, so we get 10, and we reduce the power by 1. So 10u to the power 9. Now what I want you to see next is this, that we can consider dy dx, the thing that we're trying to find, is equal to dy du times by du dx. Right? Dy du times by du dx. And if you like, It's not quite true, but if you like, you can consider this. If you treat dy du and du dx as fractions, then what you can see is that the du there cancels off and you're left with dy dx. I must caution you, that's not actually what differentiation means. It's not what dy du means. It isn't a fraction. But from your point of view, at this stage, you can kind of think of it like that. So in other words, if I want to find dy dx, what I've got to do is I've got to take dy du, that's that thing, so this thing here, and multiply it by du dx, which is that thing there. And what happens if I do that? Well, dy du is 10u to the power of 9, so 10u to the power of 9. And remember that u is actually 2x plus 3. So 2x plus 3 to the power of 9. And then we're going to times that by du dx, which is 2. Okay, so just to clarify, we've done dy du, but we've replaced the u back with 2x plus 3 times by du dx. So in the end, what we get, we multiply through, is 20 bracket 2x plus 3 to the power of 9. So how do we differentiate y equals 2x plus 3 to the power of 10? Like that, we get 20 bracket 2x plus 3 to the power of 9. Now that probably seems really very complicated, but I think it's the kind of thing that becomes more simple when you see it again a couple of times. So let's do a couple more examples. Let's start with one that is fairly similar to what we've just done. Here we've got y equals 5x squared minus 2 all to the power of 7. So what's the function on the inside? Well, here it's 5x squared minus 2, right? That's the function on the inside. So let's start by defining let u equal 5x squared minus 2. And if that's true, then y is equal to u to the power of 7. So we differentiate u with respect to x, du dx, and we see that that is equal to 10x. And we differentiate y with respect to u, dy du, and we see that that's equal to 7u to the power of 6. So we want to find dy dx. What's the rule? Well, dy dx is equal to dy du times by du dx. Right? We're going to take this thing, dy du, that thing there, and times it by du dx. Right? This thing here. And if we do that, what we're going to get is 7u to the power of 6, and we'll just replace u again with 5x squared minus 2 times by du dx, which is 10x. So if I simplify this all through, what am I going to get? I'm going to get 70x bracket 5x squared minus 2 to the power of 6. Right? And that's my answer there. Okay, well, let's do a couple more. Let's have a look at this particular one. Right? Here we've got y is equal to 1 over 4 minus x squared. Now, in order to do this, actually, what we need to do first is we need to change this just a little bit. Right? We know from our rules of indices that this can be written as 4 minus x squared to the power of negative 1. Okay? In this particular case, our small function on the inside is 4 minus x squared. So let's do that. Let u equal 4 minus x squared, and therefore y is equal to u to the power of minus 1. And we differentiate both of these. Du dx is equal to minus 2x The x squared differentiates to give minus 2x there. And dy du, and we bring the power down, so minus u, and we lower the power by 1, so that becomes minus 2. We've got du dx and dy du. Well, how then do we find dy dx? Well, dy dx, the rule is equal to dy du times by du dx. Okay? And if I just put the numbers in, well, in this case, dy du is minus u to the power of negative 2. So replacing u again, that's 4 minus x squared to the power of negative 2 times by du dx, which is minus 2x. So multiplying it out, what I'm going to get here, well, the minus signs cancel off. I'm going to get 2x over 4 minus x squared, right? Because that's what the power of negative 2 does there, right? It brings it as a fraction down, a fraction squared. Okay? But I think we can do one final example before we close on this video. So let's have a look at this. Right here, what we've got is y is equal to the square root of 2x minus x cubed. I'm just going to pause for a second. I wonder if you can tell me what you think the small inside function will be. Well, in this particular case, the small inside function is going to be that, right? It's going to be 2x minus x cubed. And we can sort of think of it actually. Again, we can change the indices like we did before. 2x minus x cubed all to the power of a half. Because you remember that the square root can be written as a power of a half. So let's do our method again. Let u equal 2x minus x cubed. Okay. And therefore y is equal to u to the power of a half. Differentiate both. Du dx is equal to 2 minus 3x squared. And dy du is equal to a half u to the power minus a half. Again, we bring the power down, we reduce the power by 1. And so what is dy dx going to be? Y dx is going to be equal to dy du times by du dx. Okay? And so dy du is a half u to the power of negative a half. Well, the u again we replace with 2x minus x cubed, power of minus a half. And we times by du dx is 2 minus 3x squared. So we put all those things together. What are we going to get there? We're going to get 2 minus 3x squared on the top over 2 square root 2x minus x cubed, right? That's what the power of the negative a half there is doing. It's square rooting what's inside the bracket and it's making it into a fraction. Okay, so what have we learned? What is really the chain rule all about? Well, going back to the first principles, a chain rule deals with a situation where you have got a function inside another function, right? So you've got a big function on the outside and a little function that's tucked inside of it. And how do you really go about solving such a problem? Well, really you just make a substitution. And what you say is you take the small little function on the inside and you let u equal that little function, right? In this case, our g of x, or 2x plus 3. And from there, you get a function y is equal to u, which you can differentiate with respect to u. You've got u, which is a function of x, which you can differentiate with respect to x. And you apply the rule that dy dx is equal to dy du times by du dx. Okay, so if you want to know what the chain rule is all about, in the end, what you're going to have to do is to learn that rule. Dy dx is equal to dy du times by Okay, guys, I hope that was helpful. And I think you should be able to proceed with the next exercise. I think it's 12.2. And so I hope you have good luck there. Take care, and I will see you